Hello everyone, I'm Binjo. Welcome back to another video. So in this video, we're gonna be looking at tree diagrams. Okay, so just to write down the title. All right, so okay, presenting probability on a tree diagram. All right, so tree diagram is one of my favorite method to present a probability because it's easy and it's clear and so on. So just to recall, so from the last video, we had done the possibility diagram. All right, so this is from the previous video. Okay, and then the next video, we're gonna be looking at Venn diagrams. All right, so this is going to be the next video. Okay, and same thing as the last video. After looking at how to construct a tree diagram, then we will look at conditional probabilities on tree diagrams. All right, so this is the main content of this video. So if it's not what you're looking for, then please feel free to move on to the next video. All right, so yeah, just to write down the title. What is a tree diagram? All right, so a tree diagram. How do I explain a tree diagram? It's like listing out probabilities through branches. All right, listing out probabilities of two or more events through branches. Yeah, so it's very hard to explain, but let's jump into an example. So the example I can give here is let's say you are given two bags of toy balls. All right, so there are, okay, let's just say one bag. Okay, in a bag filled with balls. All right, so 30 is red, okay, and 25 is blue. Okay, so the question is, let's say I draw two balls without replacement. Okay, I draw two balls out without replacement. All right, so you are going to construct a tree diagram. All right, so if you see this kind of question that says there are maybe I cannot say it's two or more events, two or more items, you know. Probability, let's just say true branches, you know, to reduce confusion. True branches. Okay, so if you see this kind of question, how are you going to construct a tree diagram? Okay, so a tree diagram starts with something like this. All right, so from one point, you will start to separate into two different paths. All right, so let's say this is the first ball being drawn. All right, so the first ball being drawn, there are only red and blue balls inside the bag. So if you go here, this represents red ball being drawn. And if you go down there, meaning a blue ball is being drawn. All right, so what is the probability of you getting a red ball? Okay, so we're gonna write the probabilities here. All right, so the probability of getting a red ball, all right, is equals to 30 out of 55. Okay, so it's 30 out of 30 plus 25 because the total outcomes is 55. You can get 55 kinds of balls, but there are only 30 of them, which is red. All right, so you can write down straightly 30, all right, 30 over 55. All right, you can choose to simplify it if this is your final answer. If this is just your working, you can choose to remain it not at the not so simplest version. All right, and then the blue ball will be usually just 1 minus this one, the complement of the branch on top. But however, in this case, we can still deduce it from there are 25 blue balls and there are 55 total balls. All right, so these are the probabilities that you draw the first ball. So since I'm drawing two balls without replacement, meaning there are another branch here, okay, so this first ball, if it's red, you can go to another further two more possibilities, and this goes to the same as the blue one. So this is going to be the second ball drawn. All right, if you think about it, if I draw the red ball as my first ball, I can draw another red ball for my second ball. All right, and it can goes the same. I can draw another blue ball instead for my second ball, and this will go to the same as the blue. All right, so this is a simple tree diagram. So but we are not done yet because we need to include the probabilities of us getting a red ball as our second ball. So remember, it's without replacement. Okay, so this is a very important word. All right, without replacement. Okay, let me check how this highlighter works. Without replacement. Okay, this color is actually ugly. Let's use yellow. All right, without replacement. So once you take out the ball, you are not putting it back inside the bag. So originally, there are 55 total balls in the bag. But since you took out your first ball, meaning there are only 54 balls left. All right, so does this make sense for you? Once you take out one ball, you are not putting it back inside the bag. All right, so there are only 54 balls left. And remember, in this branch, all right, your first ball taken is red. So when you have 30 red balls, you took out one red ball, which means you have now only 29 red balls left. All right, so you see how if you take out a red ball, then your second ball being a red one will be 29 out of 54. All right, so if we go down to the blue balls here, the total ball is still 54 because you already took out one ball no matter what. All right, so it's always gonna be 54 total balls for your second ball. But remember, it's only happening if it's without replacement. Okay, so from the beginning, you have 25 blue. All right, so since your first ball is a red ball and not a blue one, so you still gonna have 25 blue balls inside the bag. Therefore, you're just gonna write the 25 on the numerator. All right, so if you're gonna do the same to the blue side, all right, since you take the blue one as the first ball, there are still 30 red balls, but 54 total balls left. And this one is gonna be 24 over 54. All right, so this is a simple tree diagram that that you're gonna have, and this is basically a tree diagram. Okay, so how do you make sure that your tree diagram is correct? Okay, so I can write a note here. You can double check the sum of the vertical in a branch. All right, what do you mean the sum of a vertical in a branch? Okay, so this is one branch that separates into two. Okay, so if you calculate the sum of the vertical, all right, 30 over 55. Okay, let's use a different color. 30, this too light, green one. 30 over 55 plus 25 over 55, you will get the sum is equals to 1. Then you know that your calculations are correct. All right. Equally, at this part right here, you have 29 over 54 and 25 over 54. All right. 29 over 54 plus 25 over 54 will gives you 1 also. All right. That means your calculations are correct. Okay. Double check that your sum of vertical in a branch must be equals to 1. Then you know that your tree diagram is 90% correct. All right, 90% accurate, at least given that you don't have other errors. All right, so this is how you draw a tree diagram, and how do you read it is, if you get the first ball as red and the second ball as red, you are just gonna multiply. All right, multiply along the branch. Okay, so now we're gonna go to the question part. All right, the question one, they will ask you to construct a tree diagram. All right, and then they might continue with a different question. Let's say question 2. What is the probability of getting two same color balls? All right. So in this kind of condition, right, if you refer back to your tree diagram, everything is going to be very easy. So the probability of getting two same color balls will be the probability of red, red plus the probability of blue, blue. All right, so these are the probability of getting the two same color balls, because there are only two types of color. Okay, so how do you calculate this? So the probability of getting a red ball at the first draw and the second draw will be 30 over 55. All right, so this is going to be 30 over 55, and you multiply it with 29 over 54. All right, so when you move along the branch, it's going to be multiplication, because it's a it's counted as one event, so you don't sum them up. Instead, you multiply it, because it is counted as one event when both balls are taken out. Okay, so do the same thing for the blue part. You have 25 balls when at the first draw, and then you got 24 at the second draw. All right, just to double check, yes, and it's correct. So if you're just gonna press your calculator to get the answer, okay, 30 times 29, you get 870, plus 25 times 24, which is 600. You divide everything to 2970, and then you will get your answer as 49 over 99. All right, so the probability of you getting the two same color balls will be 49 over 99. All right, and if they ask you to give it in terms of decimal places, this will be equals to 0.495 to three significant figures. All right, so it's just that easy. So second, they might ask you what is the probability of getting two different color balls. Okay, so the next question here, they might ask you, what is the probability of getting different color balls? All right, so there are two methods to do it. So method number one, all right, you can use the same method as from the top. You look along the branches. All right, so if it's a single event, then you multiply it, and then when there are two or more possible events happening, then you will just sum it up. Okay, I'll write this note at the last page. Okay, so this one, the method one, we have the red one first. So it's 30 over 55. You multiply with getting a blue ball, which is 25 over 54. All right, so this corresponds to the first to the first branch here. So when you get a red one is 30 over 55 and blue one is 25 over 54. All right, and you're gonna do the same thing to the blue one. So you get the blue one first, which is 25 over 55, and you multiply with 30 over 54. All right, and then you will get an answer. So this is method 1. However, there is a method 2, which is using the complement method. So the probability of getting blue, red, or red, blue will be equals to 1 minus the probability of getting red, red, or blue, blue. All right, which is equals to 1 minus 49 over 99 from the answer at the top, which is equals to 50 over 99. And this answer right here will be 50 over 99. All right, so if you're going to press your calculator, 25 times 30 divided by 55 times 54, and then multiply 2, you will get 50 over 99. So this is the complement method, and this is the tree diagram method. So you can see which one. However, you can only use the complement method given that you have calculated the first part, right? So not sure if the face cam is blocking this. Yeah, so it's this one. Okay, so this is basically how a tree diagram will ask you about the questions. So usually tree diagrams, they'll give you maybe 4 or 5 sub-questions. So the first 3 sub-questions might be this one. And then the second part is when it's conditional probability. All right, so the same thing as the previous video. All right, so if you don't know what is a conditional probability, please refer back to the previous video. So question 5 right here. Okay, now instead, what is the probability of getting 2 red balls given the first ball drawn is red. All right, so now you're looking for a probability of you getting 2 red balls given the first ball drawn is red. So how do you calculate this probability? All right, so this thing right here, the probability, all right, let A be equals to first, you can only get 2 red balls when your second ball is also red. All right, so second ball is red. All right, and B is equals to first ball is red. All right, so the probability of A given B, all right, so this is the notation for given the conditional probability. So now, all right, we know that our first ball is red. Okay, so we can actually ignore the bottom part. All right, we can actually ignore this part down here. Okay, because it's irrelevant anymore. We are told that this red part right here is the probability that we need. All right, so what is the probability of us getting a red one? So the answer is actually just 29 over 54, right? So the answer right here will be 29 over 54, right? Because there are 54 balls left in the bag, and then we know that we must get a red ball in this time. So the probability will be 29 red balls left in the bag. So it's 29 over 54. And this is how you calculate the conditional probability. The conditional probability of in using a tree diagram. All right. So there are actually another way. All right. So method number 2, which is more of a Venn diagram way. All right. Method number 2, I will mention this again in the next video. So the probability of A given B will be equals to the probability of A and B divided by probability of B. All right, so this is the general formula for a conditional probability or condition and anything. Okay, so A and B meaning your first ball is red and your second ball is red. It is pretty much this. It's pretty much this combination right here when it's red and red. So it's 30 times 29. So from here, you will get that this is equals to 30 multiplied with 29 divided by 55 multiplied 54. And what is the probability of B? All right, so the B is the probability that the first ball is red. All right, so what is the probability that the first ball taken is red, which is 30 over 55. Okay, it's just that easy. So which is equals to 30 over 55. And then if you simplify this, you will simply get 29 over 54. It's just that easy for getting a conditional probability from a tree diagram, which is you can just read it off from a tree diagram if you have all the information. All right, so method 2, we will look at it more in using a Venn diagram. All right, it's usually shown more on a Venn diagram. Yeah, so as promised, I will write down this thing right here. Okay, note. All right, so when to use plus and when to use multiplication is usually a very big confusion for a lot of students when they are studying mathematics, when they're studying this tree diagram, sorry. So yeah, this tree diagram right here, when do you use the plus? So when it is in a same event, then you use multiplication. All right, so what do you mean like in the same event? All right, so this is along the branch. All right, so what do you mean in the same event? So this event, let's say event A, I'm asking for a red and a blue ball. So you can have this one event right here, which is red and blue, all right, or the second event, which is blue and red. So this first event here along the branch, as you can see, it connects from the red all the way to the blue. You will multiply these probabilities. All right. And then you are going to sum it with a second event giving the same condition as the first event, where you get a red and a blue ball. All right. It's just the first and the second order. So at this part right here, I'm going to write in a different let's say outcome, right, with same event, then you will use summation. All right, maybe I'll say in a single outcome. Yeah, in a different outcome but with the same event, then you will use summation, and this is usually different branches. All right, so as I mentioned, as I explained just now, how the red ball and blue ball, with the blue ball and red ball, when are you going to use multiplication? When are you going to use the addition? All right, so yeah, this basically marks everything about tree diagrams. All right, how do you calculate the conditional probability of using just reading off the tree diagram? So this probability right here is the probability given this probability right here. So in short, we can actually write this as, all right, probability of red, okay, and this is probability of blue. So this is the probability of red number 2 given our first one is red. All right, and this is going to be the probability that it is blue given that our second ball is blue, given that our first ball is red. All right, because this branch right here can only exist if this branch is created. All right, so this is R1, this is B1. All right, and this is actually the same for this. The probability of getting a second red ball given that our first ball is blue, and blue ball as a second given the blue ball is the first one also. All right, so this branch right here represents a conditional probability because it can only happen given that this probability here happen. All right, so yeah, this marks everything about tree diagram. All right, so in more complicated questions, they will give you maybe 3 branches as the starting one, so you will get around like 6 branches when it's the second event. All right, so yeah, hope you guys understand this, and I will see you guys next time where we are going to talk about showing probability using Venn diagram. All right, thank you.